Hello and welcome to the channel. Today we're going to continue with our PICO MIDI where we left off. We covered loads of things so far, right? So if you remember last time, I covered external switches. So here was the last version of our MIDI pedal. We support now configuration from, reading from file, the configuration. We can, based on configuration, decide whether this is used as expression pedal or external switches. We covered this interface, MIDI interface with different pedals, covered, all different stuff there. But what happened was that, in that I covered this, now if I use something like this Digitech FS3X foot switch, now I have 4 buttons and only one LED. Maybe we want to do something a bit more interesting. We want to do maybe some nice RGB stem effects or something like that. But there are lots of options, and there is one great thing. These are Neopixels from Adafruit. Look at them. You can get a few of them, but what's great about them is that they're the interface they have with your microcontroller. Look at them, how tiny they are. The thing is, you can daisy chain them. You can chain them and you can address each one of them independently. If you want to see more, how to work with them, Adafruit has a massive, Uber guide for this. But as I said, the main thing is you have power, so positive end, negative end. Ignore this 5 volt for now. They ideally they would be powered from 5 volt supply, but we can do that with 3.3, getting them out of Raspberry Pi Pico directly. And we have, this is data out, data in and data out. And so what this does is you can go from a microcontroller to data in, data out goes to the next Neopixel, data out goes to the next Neopixel, and let's see how that works. So one funny thing is that, you have very simple examples coming out of the box with the MicroPython. So here you have example with a bit more explanation, and a nicer example direct to MicroPython site for this is ESP8266, but Raspberry Pi Pico has the same thing, so this is as much as it's required to code for this. But before that, let's see what do we do here. How do we change this schematic? And here, this is it. We just need to, and I plugged it into a random port. Anyone will do. Yeah. Sunny Ices, right on time. Okay, so I'm just gonna wire this up real quick. So let me just get this out of the way a bit. So one tricky bit about this is that these are, surface mount. So where did I put it? Okay, took me a while to find it. So here what I did, I just soldered some wires to it, Yellow is my data in, red is power, positive end, ground, green. Let's do this. All right, so it's good to have color-coded wires around. So let me do that code real quick. If let me see. Okay, so it should be as simple as this, and this is actually just keep in mind that this is really all you need. So let me spin up Tony and let's get to it. Okay, so this one should be all white. Okay, so we are setting GPIO 8 to be our output for Neopixels, and then we set up here on that pin, we say there's 8 pixels. So I don't have 8 pixels, but it doesn't really matter. It just tells you that you can actually do this, and then you set the values for RGB values for first one, and you can add for all 8 of them, and then you just write, and then at that point it writes the value to the output. So I'm running it. Yay! Look at that. It's white, right? So let's try doing this with, let's set it to red. All red. RGB, right? So nothing happens, I would expect. Yeah, there's no change until we say NP right. And it's red. And then you can, add green. There it is. So, I mean, this is okay, right? It's super simple, super easy. Let's wire up expression pedal and run that. And I have this in, there will be a link in the description for all of this. You don't need to check this code. The code is, I copy-pasted from one of the previous videos. It's not really anything new. It is printing out the values that the adapter is, analog to digital converter is reading. But all I did was here, when I express, I changed this. I just write to red values. So as I go up and down with the pedal, the intensity of the color will change. And you can't see it because I have buttons plugged in here. So it just appears there's floating wire there, and it's reading random stuff. So let me put the pedal here. Just plug it in. Running out of space on this desk. Okay, it's there. So that's not good, right? Okay, I was caught by this before. Okay, maybe it's this. Yeah, it was that. So, whoop. And you see, it's really, oh, it's burning my eyes. You can change the taper slightly to get a better here, but you can see how you could use this possibly for some sort of a visual representation of how this works, So that was easy, okay? So as I said, you can easily chain 4 of these and they will just work, So for example, if I wanted to, I could get 4 of them for each of the, or 3 of them for each of the buttons or something like that. There is a bit of a thing about this. So I'm using 3.3 volt power supply. You can do this, and the consumption is a bit lower. So how much does it? I think, okay, they draw as much as 60 milliamps when they're all on full brightness white. And this, you see, this is Arduino can drive up to 500 pixels at 330 frames per second. Okay, that's impressive, actually. One thing, though, is that at the very, when you're driving your Raspberry Pi PICO at you know, with a very demanding application, it does not consume more than 90, or, you know, if you look at the datasheet, it says, you know, about 90 milliamps. So 60 milliamps is a lot, you know, for a pedal. And keeping in mind that a pedal that is doing this, you know, a more traditional pedal uses up to 10 milliamps. Imagine. So we want to maybe control our power consumption. So we could change the let me go back to the original code here, right? Or when I say original, the one that we tried first, you know. So let me do that. Stop here. Let me run this. Okay, so this is white now, and it is at the highest consumption. So if we go and we change this, for example, we can control the brightness of this. And if I do maybe 127, 0, and p dot right, so this kind of a, you know, it's still very visible, you know, and we can go all the way down to maybe even, let's say, what, 20, let's say 20, doesn't really matter. You know, you can still see it, it's not great. And it helps with consumption that we are using 3.3 volts. It consumes little less current, but you don't get versatility of the Neopixel because it is at its best when it's at full power. And it's really amazing that way. So what we can do is we can use PWM modulation to control a regular LED. So for example, how would that work? So if you use something like that some LED, say low current LED that is very efficient and consumes maybe very little current. Let me just switch off this. So let's say controlling brightness with PWM, with pulse width modulation. So this is just a way to control. PWM pulse width modulation is used for many things, so you can go and check it out. But in our case, we have this duty cycle where we keep the output on or off depending on this duty cycle. So 50% is on, is 50%, 50% is off, duty cycle. So this is how the output looks like. And by doing this, you kind of control the brightness of your LED. So luck would have it that on the simplest examples for children, we have this code that is exactly where my LED is. Okay, so let's use that and see how this looks like, right? Run this and keep an eye on that red LED. And you can hopefully see how it pulsates. So that's relatively easy, right? If we look at some of the other documentation that we could look it up, you know. You can look at here at a Raspberry Pi PICO reference. It says it has 16 PWM channels in total, which is Good. So we can, for example, use our own RGB LED maybe to control, to maybe get a better power efficiency, okay? And what that gives us is a bit more control over our power consumption, and maybe we have more flexibility. When it comes to, you know, using your RGB LED, and I have it somewhere here. Yeah, I have it here. So let me just remove my Neopixel. You saw there, it's using 3 wires and 2 are power, and we only use 1 GPIO of our microcontroller. But if you want to use RGB, we actually need a bit more GPIOs, and that might be a problem. It's not a problem here. We have loads of GPIOs still, but it might be a problem when it comes to some smaller devices, because I do have smaller devices that have maybe less GPIOs available, and that might be a problem later on, you know. So let me see if I can show you that. Yeah, so look at this one here. That's brilliant, but has less GPIOs than full. But obviously, it's smaller. It can fit in a smaller enclosure, you know. So it depends on what you need it for. But let me wire this up. Okay. Just get these, and I forgot to show this on the diagram. So this is what we're doing, right? Oh, it's common anode. All right. Good that I looked at the diagram. Right. I hope this is visible on. So no, this is a clear diode LED. So one thing to be wary about is that blue and green, they might have 3 or over 3 something volts. So they typically have 3.2, and we're driving them from 3.3 volt. So the drop might not be enough to what you call them, to it's not enough to possibly even light them up. Actually, because we are using lower current, the drop is smaller, so you know we should be fine. But one of those things that you have to look into datasheet and make sure you select the correct diode for the job, you know. So here, let's go through this briefly, and this is one of those, you know, I just picked it up from the basic examples. So we have this, we chose the pins, R, G, and B, 2019, 18, have them there, R, G, and B, okay. That's how I plugged them in. PWM, this is just a driver for pulse width modulation. Frequency is going to be 1 kilohertz. And then you have this duty cycle. It's from 0 to 65,025, which is 16-bit number. Okay, unassigned 60-bit number. So this is handy actually, because your analog to digital controller goes that way anyway. But let me run this, and we should be seeing this, you know, pulsating here. And I don't know if it's visible on the camera properly. I'm not really sure. Yeah. See how it is pulsating. All right. And then, you know, but you can easily control, you know, some of them you don't need to do this, so you can, you know, run it like this. So this is a clear diode. So again, I'm not sure how it's going to come across on the video. It's better if you have a diffuser on it. Speaking of which, I have a diffuser. Okay, hold on. I'll find it now. All right, yeah, I have loads of things lying around. I don't even know half of them. Okay, so is this better? Nah, not great. This is not diffuser. This is just I don't know what the name is. Yeah, that's not great, isn't it? For the video anyway, it's great if you. But for next time, before I make a decision what I'm going to put in the pedal, I would have to make this decision, you know. And you can see here it's a bit. Oh yeah, what's happening is I should put here, probably I should set this. So yeah, to do it properly, because these keep being on. And I'm just gonna, because the way, this is one of those things, you know, I selected wrong LED. So if it's driven down, it will be on, and by default it will be down. The pins. So it's a bit kind of a, what you would want to do is, let me see that. Okay, I got it. I got it. Okay, I'm an idiot. Yay! So yeah, you can, you know, this is one of those things, you just need to know what you're doing, obviously. Today, it's not my day. Okay, so this is what we covered today was Neopixels, very simple, very beautiful little devices. They have loads of, you know, you can use them very well, you know, and the only downside of them is power consumption, and you know, we can't really control that very well. Ideally, if I could find something like that just for low power diodes, you know, low current diodes, that would be great. Again, remembering that the traditional guitar effects can consume under 10 milliamps, so we need to try to make this reasonable, you know, because my cheap power supply is driving maximum 120 milliamps, you know. So we would want to limit, if you want to power your pedal with something like that, you need to limit the power consumption. So Neopixel will probably not going to be your choice. My choice won't be, just because of that. It's super easy to use, super, it's great, just that's not, I just can't use it. So I'm just guessing it's going to be probably some RGB LED, or I'm just gonna not do anything and just not having this indicator, maybe. But having said that, we still need to deal with power supply, because you know, we don't want this pedal to be connected to computer the whole time. So common guitar power supply uses 9 volts, so makes sense to do that with that kind of supply. So that's something for next time. Until then,